Hello? So today we will speak about microservice best practice for Java architects. First, I'd like to set the definition of microservice. What's a microservice? What is it? Hey, we are returning from the lunch. What's a microservice? Maybe from its definition. Any thought? Okay, how many of you worked with microservice? Please raise your hand up. So I think that you have the definition of microservice, right? Or at least from your perspective. Okay, microservice from its name, it's a microservice. And please don't say it's a small service, okay? It's a microservice. Service, it can be an API or a component or a web service or any such stuff. Micro, it means that it's a single thing that do well. From which perspective? From the service user perspective, okay? Because I find some developers that define a microservice from a development perspective. And that micro can be small service or big thing. Small service like small collection, making a crowd of the over database. Big things like multi-order fulfillment or multi-transaction inserting multiple records in multiple databases. For those who are planning to work in microservice, that's the ideal way, that we have a straightforward direction with a steady flow that we can build our microservice. And that's my thought when I start to work in microservice before I lead it in IBM, that I have a simple, an elegant way, an easy way to build a microservice application. But after a lot of engagement, I realized it is not like that direction. It's that one, okay? Do anyone who had hands-on practice in microservice feel that microservice turned his life in that direction? Yeah, yes. You are not the only one in that country. Okay, so from the definition of the microservice, that we have a multiple service. Those multiple service, it's built according to the client business perspective, and usually we have an identity provider or API gateway to facilitate the calling from the client side to the microservice orchestration. And actually, microservice is not a new trend or something like that. We usually started to build our application like a monolithic application in two tiers or 3 tiers, 5 tiers, and that stuff. Then, in the era of the integration, we start to build our application in the service-oriented architecture. And then we started to orient our service to be deployed independently. So we started to think more about the microservice architecture. Actually, microservice architecture or solution architecture of the microservice is not entitled with microservice only. Did you face some mismatching or alignment between microservice and API management? Cloud platforms, containerization, and microservice. Actually, to build a robust microservice application, you need to interact your microservice with an API, container, and the cloud platforms. So if I want, I will not spend a lot of time here because I want to go through the best practice rather than speaking about that content. To build a cloud native application, you have to fulfill the 12 factor of cloud native application. How many of you know cloud native application 12 factors? Okay, I'll speak it in maybe a couple of minutes, but if you want a comprehensive description for those 12 factors, you will find it in the 12 factor website. And also my colleague Emily from IBM had a session that's recorded last year about 12 factors of microservice. The first one, it's a code-based, that you should have a repository for our code-based application, a single repository that collects all our code for all services. I think that's all of us usually satisfy that, right or wrong? Because it's an essential part for working in a team nowadays. Dependencies. When you are thinking about a cloud application that you have a multiple service that you need to isolate the dependencies between each other. You should store the configuration in the environment itself. Don't store it in the local storage or that stuff, because in cloud environment, usually are not knowing where is your file stored or what is the location. Sometimes you have where is the availability zone or that stuff, but you are not aware what server that you are saving your data. Build, release, run. Separate the build and run. I will not go through all those processes, but let's start in the what is the design principles for microservice. Do anyone want to share what is the design principle from his lesson learned? Let me share mine, okay? Now we will discuss 8 principles. The first principle is called modeled around business domain. The second one, it's culture of automation. The third one, hide implementation details. Fourth one, decentralize all the things. Fifth one, deploy independently. 6, consumer first. 7, isolate failure. And 8, it's highly observable. The first principle, how to model our application around the business domain. We agreed that our microservice should build in the direction of a business service, right? User business service. To build that, let's have an assumption that we have an application like a monolithic application. That application composed of 3 tiers: the data access, the business logic, and the presentation. And then we need to add a new fields. That new field should have an effect on the data access layer, sometimes on the business logic layer if it's incorporated within existing business, and at the presentation layer if I need that attributes to be shown to the client or maybe populated from the client. But usually we have, for every and each layer that we have a team that work in that layer. So I need to communicate that message between all those teams. In the domain-driven layers, or the domain-driven architecture, I have an application layer, a domain model layer, and infrastructure layer. The domain layer have no dependency over any other of those layers. The application layer should have dependencies in the domain layer and infrastructure layer. The infrastructure layer have dependencies in the domain layer. The second point is culture of automation. Let me share with you the nightmare that we have a production release tomorrow, and we are behind the schedule as usual as the developers, and we need to run a test cases and to automate our build. I think that's usually our case, right? So nowadays we are not thinking about the application from a monolithic layer or monolithic WAR or EAR file, or even the 3 tiers layer. We are thinking about the service, is the individual service itself. So think that we have the life cycle, build, test, integrate, UAT, and production. We have a service 1, 2, 3 that's going through those process. Then we have another service that have a higher business requirement or demand that we need to go faster. Nowadays, we have to manage those 2 services, right or wrong? Because I can deploy each service independently. So I should think about continuous delivery. So to be able to build a continuous delivery pipeline, we need to think more about the infrastructure that we have. We will start with the API-driven machine provision. That I need to provision a machine or a virtual machine automatically, or sometimes like a code or using some scripts. Most of the cloud providers do that, and also the DigitalOcean, Vagrant, and VMware, we can build that scripts. So now we have built our virtual machine or provisioned it automatically, like that script code that's built our maybe Ubuntu server version 1, 2, 3. Then we need to configure our operating system also not in manual way, in an automated way. So like we have an Ansible or Chef, we can write the scripts that say that I need that operating system and install that bunch of software or that bunch of runtime before I start to do anything. Nowadays, we used to not provision a virtual machine itself. We need to provision an image. And the most famous one, it's a Docker image. We hear a packer that can create an image that was created from an automated virtual machine and configured using scripts. Nowadays, the cloud providers, we know that we have a PaaS, IaaS, and SaaS. Now we have CaaS, which is a container as a service that I can avail a container as a service. Like I requesting a container with that configuration, and the cloud provider or maybe even the private cloud provider can issue that. Declarative environment provision. Think that I'm now testing in an environment, so I need like only a single virtual machine, did the development tasks, testing tasks, and I want to go to the production. I need to build my production environment with the same configuration, but with a scalable environment. Like I need to make the same configuration, but it's not like one virtual machine or one Docker image. It will be 12 machines. Docker and Terraform, Kubernetes playing a very good role in doing that. But things about that, now I automate the provisioning of the environment. Nowadays, I need to automate the testing environment itself. And when I'm saying testing, I'm saying that's the end-to-end test cycle. Think that I have a service A, that service A call service B and C, and that service B call another service B, maybe B dash or something like that. And if I have a change over service P, which service do you think that I need to test? I'm changing that service only, right? So which service that I need to test? Which one? All of them, right? Sometimes, yes, all of them, because that's has a dependency in here, and that's may have a dependency in there. So I need to test the life cycle. So I have to test all the service. And is it applicable in real time? That's each change for every microservice I have to test. That's the right, or that's maybe the best scenario. But is it applicable in our life? Keep it in mind that I'm not releasing a version with the system. I am releasing a version with a microservice from a system which composed maybe hundreds or thousands of microservices. So I need to build a test book or or an automation testing. Automation testing is starting from the unit test, the service, and the UI. The UI, it's increased in scope and more complex, and unit testing, it's usually the faster and easier. Hidden implementation details, and that's one of the main pitfalls that the developer or the monolithic developer fall in when they are trying to build a microservice application. Think that I have a product microservice and I have a shipping microservice. So that's have a context and that's have a context. Each of them have a product, right? Please, you have to set the boundaries between the product from the product context and the shipping from the product from the shipping context. And because if you did the tight coupling, that's every and each change in the product service, in the product entity, which needed from the product context, you have to change the product even if you are not using it in the shipment context. Okay? So we need to separate the context between each service. Second point, that's hide your database. If you have a database, please have a CRUD operation or the microservice that handles the transaction from that database. And if you have a microservice, other microservice that need to handle the same database, please don't have like that pattern, because you will not have an owner for the updating in that direction. What can we do to solve that point? That we have a microservice that have a CRUD operation for the existing database, and every microservice need to do some database manipulation should call a service from that service. So now, who is responsible for the CRUD operation over that database? It's microservice 1, 2, 3. So the accountability and logging and the traceability will be much easier. Client libraries. If we have a version of a microservice and I have 2 client services, so I need to build a client application for the service that have a version 1.3, right? If I need to build a new version of that microservice, so I need to update the client library. Please be careful in that way and try much better as you can to use it and as an abstract layer to minimize the dependencies and the changes between the parent layer or the caller and the colleague. Decentralized all things. When we are thinking about microservice, we are not centralized anymore. We have every service have its own orchestrator or choreographer, its own database sometimes, and its own environment. So don't think about this, about centralized environment in microservice. We have autonomy. Autonomy means that we can let every people have a freedom to do what he wants. But if we have a microservice, that microservice have a front end and maybe integration on middle layer and a back end. Most of the microservices have that structure. Please use an owner operator. The team owns the service in its life cycle. Sometimes they are the Scrum team or any agile team that's composed of those team members that can build that microservice, because if you don't include all of them, by the end of the Scrum, you will have or the sprint, sorry, you will have I have the back end, the database, but I don't have a front end, so I can't release the microservice by the end of the day. Be aware about your smart middleware. Usually in microservice, the straightforward, like I have a front end and integration layer and the back end or data store, it is not like that in real world. We have a multiple service. That's multiple service communicate with other services. So I need to have a middleware, ESB, or a choreographer in the middle to orchestrate that one. And the integration between microservices with each other, that we have 2 patterns: the synchronous communication and asynchronous communication. Do you think which one is better than the other? Synchronous or asynchronous? Who says synchronous? Yes, please. Synchronous or asynchronous? Asynchronous. Only one says asynchronous? 2? Who said both? Perfect. Yes, it's according, I think it's the buzzwords that we use to answer when we get inside any question. It's according to the case, right? But really, it's yes, it's according to your case. Synchronous, it's an easier to implement and to reason about, but it's, thinking about synchronous, that if I need to have a multiple calls, that I send that request and send for the response, then send another request of another service and for that response. So we have a less space for concurrency. But in the asynchronous, it's more efficient and very good in the job or patch processing or file processing, but it's increased the complexity and it's changed the troubleshooting and the testing like it's a nightmare. For the orchestration, we have 2 patterns: the orchestration or the choreographer. Orchestration, that we have a single point here in the middle that's accept all the requests and return all the responses. And it has the ability to call, not the ability, it's the responsibility to call which service and accumulate the feedback. So think about this. I have a request. That request need to call the 4 services A, B, and C, and D in a regular manner or a respective way. So the orchestrator sends the request to service A, gets the feedback or the response, then for service B, C, and sometimes make some change or aggregation, then it's returned back to the client. Other way of doing things, it's a choreographer. That's I have a request that's go to service A called service B through registry system or registry service, and every and each service knows which service shall it call. Actually, that's maybe build a loose coupling, because every and each service call each other. with an intermediate layer, but it's increase the complexity of testing and for the troubleshooting. If I want to say that I need to settle single principle from this session today, I think that's deploy independently. And most probably, in my engagement in a microservice, I used to say, please don't build a microservice application because it is not the right style for your environment or for your code. But if I can or I need to deploy the service independently, most probably I'll go to microservice. So I need to isolate like an isolated environment virtualization or even isolate the container or a Docker image. Think about that, I have a shipment service, and shipment service need to handle a consumer service. In the production environment, usually I used to maintain multiple services, right? Especially in the API economy. That's I build a service with a version and I sell that service, and a new customer or new client need updated version of that service. So I need to build another one. Here I need to handle two coexisting microservices. Here I need to have a service discovery. Service discovery from the perspective of service, or even from the perspective of the endpoint versions. Sometimes I build an endpoint like to make some conversion or wrapper. So I need to maintain also an endpoint version. So what is the deployment option or deployment strategies? I have 3 deployment strategies: the blue-green deployment, the canary deployment, and the rolling deployment. The blue-green deployment, I have a production traffic, I have a load balancer or router that's load the traffic to my production servers or maybe the container images that I have. Then I build the new, that's the updated version. Then once it's ready, I change the traffic from the old version to the new version. What is the pros and cons for that? The issue that I need to build a parallel production environment that maintains the newer or the updated version, right? Because I can't wait to kill the old versions and deploy the new version. I need to minimize my downtime. The another one, it's called canary deployment. I have a router that's routes the traffic to a couple of container images, and I have a newly, sometimes well-tested or not well-tested, and I need to touch the market with that, right? Facebook usually do that. Do you know that or not? That's usually deploy a service to a specific user or a specific location or a specific category of users. So what they are doing, that's they are it changes the traffic balancing from 100% from the old version, like maybe 90% to 10%, and tests that environment in the new deployment. The another one, it's calling rolling deployment, and we use that when that direction in non-transactional systems. That I have, that's my clusters or my Docker images, and I try to roll a container and a container and a container. But usually I use that one in like inquiring and that stuff that's not having a transactional database, right? Because if I change it, the way of doing a transaction, I have inconsistency in the database from the updated versions and the not updated one. So actually, I need all those 3 categories or way of deploying a microservice application. Usually, I need to manage the MTBF or MTTR. It's mean time between failure, which is the time between every and each failure of our system. And the MTTR, the mean time to recovery, the time that the service take from its down till it's be up. Okay? Did you understand the difference between the two? That's I have, as the system had been down or crashed that month, then after 2 months, it had been crashed again. So the MTBR, it's 2 months. But the MTTR, that's now it's 1 p.m. and the system had been crashed and it's come up at 1 and 10. So we have 10 time MTTR. Consumer first. Please, please, we building our microservice not for our sake, it's for the business user. So we need to work with the consumer like in an agile way, meet with him frequently, maybe monthly, daily, or weekly, and try to build a contract between you and your client, and educate your client how can you build that. Even you need to educate your technical clients, okay? When we are trying to documenting the API, don't think about the documentation of the document and that is the stuff that what we have. We need to go to documentation tool like Swagger, so I can easily communicate for myself and for the external team at the same time. In an API, we need to build an API layer, and that API layer should facilitate the integration or the calling between the client application and the microservice applications. So usually we have an API layer, and that API layer know which service shall it call. And most of the cloud providers have their own API layer, like in Amazon or API XL. Service discovery. In an API economy, I have a multiple service, and for each and every service, I have a multiple version. So I need a way to facilitate deploying or publishing the service, the way how can I call it or access, and also how can I deploy or deregister the service from my registry. The service discovery, sometimes we build it in a server-side discovery or client-side discovery. Server-side discovery, that's like it's in the load balancer. Some matured load balancer can work as service discovery in the server side, but it's simple, it's easy to trace, it's centralized in the servers, but it's have like more hubs in the network. Sometimes I need to build a content delivery network platform for doing that. And sometimes I have to build a client-side service discovery that the client itself should have that's taking a decision. But the drawback for that one, that I'm exposing some information about me, even if it was masked or DNS to the client. The second thing that I sometimes tend to couple the client to my technology or to my infrastructure because the discovery is done in the client side, not in the server side. There's a lot of tools doing that, like Zookeeper, etcd, and Console. Monitoring, or a service discovery needs to be monitored resilience, because I have a new layer. That layer should facilitate or orchestrate the calling of that service. So I need to think about the timeout of that service. If the service didn't respond to me, shall I reply back to the client, or what can I do? Please take care of the operation team and the infrastructure team in the environment of the microservice, because their life in the microservice environments, it's a mess. Because they are not monitoring maybe tens or hundreds of servers, they actually monitoring thousands or millions of Docker images or microservices. So try to use a human registry that facilitate all the components, like what is the Docker images that are up and running, which image has been crashed, what is the logs that's being fired and make some problems. Isolate failure. Microservice by its nature, it's not reliable by default. Because if I have a multiple microservice calling each other, and I have a single service in the middle that's failed, what is the flow of the microservice, of the entire microservice? It will fail. So I need to build my application to have a fault tolerance, like if it's didn't respond in that way, I can call another one or ask for the load balancer, or maybe return back to the client with a bad response. Highly responsible, I need to build a standard monitoring that's I have a standard monitors like Docker start or collect TDC or another according to the operating system or the utility of the environment. But Best practice of logging in microservice that I have to have build a centralized log store. Please don't rely on the localized store or the localized log of the Docker image, because the Docker image itself, it should be a stateless. If I've missed that Docker image, I will miss that log. So please log locally and transfer it to centralized repository asynchronously. Make it searchable. Use a correlation ID. If you are thinking about a microservice that's handling the request from microservice to another microservice to another microservice, I should trace all those requests from the early beginning till the end. So I need to have a correlation ID from the early beginning, and that correlation ID will be my identifier of the service for every and each microservice. For monitoring, I should have built a KPI and SLOs for the entire microservice. What is the response time for microservice? When should I return to my client with a timeout? Let me ask a quick question. When should I use microservice? That question, please, if you went through a microservice engagement, I need to ask it, why or what do I need to achieve? Do I need it like build a microservice because my client came to me and said to me, please, I need to build a microservice? Some clients do that, right or wrong? If you assess the client needs that he is not needing a microservice, please don't go to the microservice. Sometimes it's an organizational alignment. That's if I have a matrix organization and that matrix are responsible for delivering a single unit that can be delivered to the client, so microservice may be one of the adapters or accelerator for doing that. Adopt the new technologies faster or using a multiple platform. Sometimes I have in my organization, and I have a Java team, .NET team, Node team, and in monolithic application, most probably we build an application using a single programming language, right? And maybe 99.9% the same database. But if I'm thinking about a microservice that I can build an application in maybe front end using JSF, JSP, or ASP.NET, or Angular, and I have a middle layer, an integration layer, maybe Node.js, or CDI, or whatever I need, and I can build a single or an individual database that stores the data for the microservice, and here I can use a SQL database, NoSQL database, graph database for the need for the microservice, right? We all know that's like a graph database, it's very good in the searching. So if I'm building a client or I'm building a microservice for searching or like an item repository, I can use a graph database. The graph database, it is not the suitable database for building a transactional management. So I can build a SQL server or an Oracle database for the transactional management. In microservice application, I can do that easily because most probably I have a data store or a database for every and each microservice. So I can select what is the best fit for such microservice, not for the entire solution. If I want to think about the scalability, I need to scale out microservice architecture. The scaling, we have two scaling modes, scale up or scale down. Vertical scaling or horizontal scaling. Vertical scaling, that's I have a server with 1 core and 2 gigabytes. Then I can scale it up for like an 8 cores and 16 gigabyte and blah, 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 till the limitation of the hardware capability that I have or that I can pay. But the issue, even with the biggest offer, I have a single point of failure. If that server crashed, so my service was crashed. The horizontal scaling, I'm building a node or a container with a specific capability. Then when I need to scale, I replicate that container like I have 2 nodes, 10 nodes, 100 nodes. And here it's very good way to fault tolerance. If that's container, if those 10 containers, I have 4 or 5 of them are down, I can work with 50% of my capacity. And also, it's from cost perspective. Usually, when we are scaling, vertical scaling, we have a point that the price it's peaked, because you have to pay the premium price for the high technology or the high RAM. Here, no, it's most probably it's a commodity servers that we need to build. Sharing nothing architecture. Sometimes I face that I build a microservice or an application server that's requests the data from a data source, and that's correlated with multiple servers or multiple nodes. Here we have a single point of failure. If I have that database, it's down. It's all those servers are down. Also, from a scalability perspective, I can scale those servers in a horizontal scaling, but that one should be scaled in a vertical dimension only. What I need, it's a concept called sharing nothing architecture. That's I have a cluster of data stores and when I'm requesting data from those data stores, I call the cluster itself. So I can vertically scale the application and also vertically scale the back end. Sometimes I need, not sometimes, oftenly I need a load balancer, and that load balancer needs to work in to distribute the load. Sometimes I need to distribute the load eventually, or sometimes I needed to make it like in the canary deployment with a percentage, and that percentage can be changed. Service discovery. I spoke about service discovery. Let's spoke about the design practice and tips. When you are designing a microservice, please spend a lot of time to identify the right boundaries of the microservice. What are the functions that this microservice should behave? Is it correlated with those services, or it is not correlated and need to build another microservice for doing that? Please don't call the infinite loop that service calls that service like in that service A and that service B. So service A calling service B in certain situation, and sometimes service B call service A in another situation. So in that dimension, we failed in infinite loop, right? Sometimes I need to call a function, so that function call another function or a service in another microservice. That microservice inside it should call another microservice in the parent service. The second one, that if you have an orchestrator or a load balancer that facilitates the traffic for the data stores, please don't overcome that traffic using that's an ad hoc connection or that stuff. Another thing, that's if you have a microservice and all those microservices have an integration microservice that's communicate with a database, please replace those microservices or internal microservice with a single consolidated, even if it was a microservice itself, or maybe an ESP or an API management tool. Sometimes we have some anti-pattern or anti-pattern for building a microservice. If you are thinking that I have a microservice A, P, and C. A need to communicate with B with a certain amount of data. B need to communicate with C with a certain amount of data. So the normal situation, that's I send that data from A to C, and then send some data from B to C. The anti-pattern, it's passing through. That's let microservice A calling service B to collect the data that it needs, and they make a single call to minimize the time out and the latency time between the communication between the microservice. Because we minimize the communication, it is not like 3 communication, it will be like only 2 communication. Cascaded change. If I change it, if I did some modification or a change in that microservice, sometimes it's reflect in another communication to the parent, then the parent. Then I need to build an abstract layer or an isolated layer between microservice and each other to minimize the change. We have here a hexagonal architecture that I have a core domain. That core domain built inside the application domain, and application domain built inside the the infrastructure domain. Did you think about migrating an existing monolithic application to a microservice application? How many of you went through that migration flow? How many? Is it good or bad? Hard or easy, maybe? Easy. Perfect. Yes. Usually, we need to wrap up with a single microservice. Even if you are building a microservice, please don't try to make like it's called a big bang. That's I'll change all my system to be a microservice application, and I need to wrap all my service to be a microservice one. No, please start with a single service, make it from end to end till its delivery. If it's success, please start to enqueue another service. Usually, we need to prioritize according to the complexity of the domain. Please start with a simple microservice. Don't start with the big microservice, because usually it will fail. If you start to migrate the big microservice first to have like a big bang or to have a major change, you need to touch the environment, the organization, the user, and also for your development team, that's you need to assess their capability to develop, test, and operate that microservice. We have a pattern called the strangler pattern. That's if I have those are a service that are communicating with each other, and I need to build a microservice application. Yes, we usually build a monolithic application, or we actually have a monolithic application on the ground and we need to migrate it to the microservice. Then we start to build a strangler pattern or a facade and make the callers to call that facade, and then that facade calls all the existing service. So we just introduced that layer to facilitate communication. We develop our updated microservice. After that, we can change the calling from the facade, from the old service to the new service. Usually, we build that pattern or a strangler in a transition period. And it is the time period from you are starting to migrate from a monolithic application till you get rid of all monolithic service. You have a strangler intermediate layer. That layer should receive all the calls from the service and communicate it with the updated one. Sometimes that strangler service itself, it's also a microservice. Okay. Sometimes in a production environment, we use an ESP or business bus to do that orchestration or choreographer. Then when we have the service, see that we have here a microservice. No, it's an old service, and we build an updated microservice. Then we will remove the calling from the old service to our updated microservice. Migration tricks from real cases that I faced several times. Please avoid a big bang, because usually the big bang change result in a complete failure of the situation. We need to keep our data synchronous. Sometimes we need to sync the data in multiple data stores, because we are not aware about the synchronization or the think about a service that stores the data in a database, and I'm building an updated microservice application using its own database. Then if I make an order in an old database, it should be reflected in the database for the another one. Here, it's the URL that's I told you about. That's the first URL. It's the 12 factor for cloud application. How to build a Docker and a Kubernetes using Java. It's a case studies using a sample code. How can you build your container and do that stuff? That's a repository of my friend Reza Rahman, which we deliver that session before. How can we build thin war Uberjar or whole Uberjar? And also, how can we build a microservice and scaling it up using using Kubernetes, and also how to build a microservice using the DevOps in the cloud. Thank you very much, and if you want any question or support in a microservice, please ping me in a Twitter. That's my Twitter handler, and thank you.